quick update on the chicken coop and these feeders that I've made for them. I've seen a bunch of different designs for these online. And basically what the concept is you have like a silo essentially of PVC that comes down to a sanitary Y or a septic Y. And these are irrigation or outdoor drainage pipes. So they're the thinner version of the PVC. So they're actually a lot cheaper because they're not bearing any load of pressure inside of them. And you see I left one of them out to kind of show you the reason for this internal piece here. That's just a step down adapter. It's a 3-to-3, and what that does is it extends this opening down further. And why that's important is because in material science, there's a thing called the angle of resolve. And what happens is in any given material, there's a point where, and if you've ever played with sand at a beach and watched it, you can pour it, and then at a certain angle, the pile will form its runaway angle. That's the angle of resolve. That's the angle it wants to travel down to. So if that's a pretty wide angle, then if it comes from this edge up there, the angle would actually be over this here. So it would actually just continue to pour the material, or in this case, the grain out. If it were a bigger grain size, you might have less of a runoff. But with this particular type of feed, it's very small and wants to resolve very quickly out of this angle. So what you do is you put one of these little adapters in, and what that gives you is it starts the angle of resolve down here. So then the bleed off actually just hits this little rim right here. I'll fill this up and show you what that looks like. And so that's with, I think it's about up to here of the grain inside it. And you can see it stops just before this lip because the angle wants to be there. And if I dig away, you can see that it just keeps falling. So if I actually dig it onto this, it's actually more practical. You can see what's happening. As they pull it away, it just keeps redispensing. And these little openings mean that usually you won't get as much fecal matter inside here because birds are really good at pooping on their own stuff. So this should be a good method of keeping an enormous amount. Each one holds about 2.5 gallons, and they stand like 44 inches tall off the floor, maybe 45 inches tall off the floor. So I'll bury the first 2 inches into the material, the bedding. They have about 2 inches in there. So as chicks, they should be able to start using these. I'll keep the other feeder in there and transition them. But yeah, that's the pipe silo setup. And interesting fact about this angle of resolve, I have found that when cooking rice in a normal pot that's about 6 inches in diameter, no matter what volume I fill up of water, if I pour the rice into the center top as it resolves into the pan, as soon as the water is crested by the rice as it piles up inside, that's the perfect ratio for making the perfect batch of rice. But let's go check on those little chickens, and I'll show you the new shed. It'll be a little tricky because it's dark out. So this is a 7x7 Craftsman shed. You can't really see it here in the nighttime, but inside are the little chickies and all their bedding and whatnot. I'm going to do PVC shelving all around it, so it's all plastic and galvanized steel, so I can pressure wash it once a month or so to keep it clean. And I just got a thermostatic relay that turns on the fan, and I'll have it turn on the heat or the little brood light for them in the meantime until they are completely warm. I made a little gate right here, and they're doing great for what it's worth. And I don't know what else. Oh yeah, I'm gonna actually build that same PVC. I'm gonna do an internal skeleton that runs up the interior walls and makes basically a grid that I'll build my shelves off of for the chickens to give this kind of room some dimension vertically for them. But those tubes will be all rainwater that I'll collect off of this thing's little roof, and then it will act as a thermal mass inside of this building. So as the heat outside is hotter, it'll take longer to heat this space because of the thermal mass of water inside it. Greenhouses often use thermal masses to regulate temperature, so I assume for them it'll be a good way to store their water and get some use out of the weight of water. So yeah, that's about it. I'll do some updates this weekend.